warm welcome to all the viewers. In today's session, we will be talking about what is variance, standard deviation, covariance, and correlation. Yes, often we come across these terms in data analysis, but sometimes we are confused that what do we actually mean by them? How to calculate them? So I'll be showing you how to calculate them and I'll be showing you the relationship between all these four terms. How are these four terms related? As you know, AMOS is useful to conduct covariance based structural equation modeling. That's why we call it CBSEM. Whereas Smart PLS does variance based structural equation modeling. So here we have a distinction that AMOS works on covariance whereas Smart PLS works on variance. And we often come across the term correlation. Every type of data analysis is related to the correlation between the different variables. Whether the correlation is high or whether the correlation is low, that helps us to arrive at the conclusion of our hypothesis, of our framed objective in research. So let us first understand what do these terms mean. Variance is a measure of how far a set of data are dispersed out from their mean or average value. So, if there's a single variable and there are data points or responses on that single variable, suppose the marks scored by the students in a class. So, if there are 20 students in the class and they secure different marks, so how do we come to know the variance? Variance is actually how far these set of data points are spread out. How far are they from the mean score of the whole class marks? So, how to do that? First, calculate the average or mean of all the scores. Then, subtract the average from each individual score. Then, square up the given number. Take the total of all squares divided by number of observations minus 1 for sample. So we usually do a research on the basis of the collected sample, not on the entire population. That is why in the formula for calculating variance and standard deviation, you see n minus 1 in the denominator rather than complete n, which denotes the number of respondents in the complete population. So in case you know the complete population, then you can take N, the capital N, which means number of respondents in the population. Otherwise, usually we take N minus 1 for a sample. Then what is standard deviation? It is simply the squared root of the variance, which tells us amount of dispersion or variation in the observations. So when we take out the square root of the value obtained through variance calculation, that is known as standard deviation. How far are these data points from the mean? So that is standard deviation. Covariance. Then we talk about covariance. So in case there are two variables, then covariance helps us to determine the direction of relationship between these two variables. Direction of relationship between these two variables. It means if one variable increases, the other decreases or it also increases. So that is we come to know through covariance. How to calculate the covariance? First calculate the average or mean of the scores of each of the two variables independently. Now subtract the average from each individual score. Do this for both the variables separately and then multiply the results of variable x and y. Then take the total of all multiplications done in the rows and divide it by number of the observations, that is again n minus 1 for a sample. But in case you know the entire population, then you divide it by n. So here you see the formula for the covariance for the entire population, where X bar stands for mean of the population. This X bar is the mean of the population, and this N is the number of people in the population. For a sample of the population, which is most frequently used in research, we use N minus 1. That is, N stands for number of samples taken minus 1, and X bar here stands for average of the sample population. So now we understand what is variance, what is standard deviation, and what is covariance. Now, if we want to know the strength as well as the direction of relationship, covariance just tells us the direction. But if we want to know both, we do correlation. So correlation between two variables by standardizing the covariance value between -1 to +1. Correlation coefficient denoted as small r, which we all know. So correlation gives us the standardized value of covariance. It measures the strength and direction of linear relationship between two variables and ranges from -1 to +1. While R squared measures the proportion of variance in the dependent variable that is predictable from the independent variables. I have a video on R square, adjusted and real R square. You can go to my playlist and check on the video on that. Use R, which is coefficient of correlation, to understand the correlation's nature and magnitude. That means if -1, that means negative correlation, perfect negative correlation between the two variables. So if one increases, other decreases. If I say +1, that means if one increases, other variable also increases. This is perfect positive correlation. If there is no correlation between the two variables, then the value of correlation comes to be around 0. 0 means no correlation, right? Even if one variable decreases and other also decreases at the same time, then also we call it positive correlation. But in case one increases and one decreases, then we call it negative correlation. I hope you have understood the term correlation. But how to calculate correlation, how to standardize the value of covariance to get the correlation value. So correlation between X and Y, denoted as R, small r, covariance of X and Y, the value which you got through the calculation of covariance, divided by standard deviation of X multiplied by standard deviation of Y. So now we already know how to calculate the standard deviation of X, standard deviation of Y, multiplying both the values and taking it as a denominator in this equation. So you get the correlation value between X and Y, which are your two variables. And this value will be between -1 to +1, so that you can determine the type of correlation between your variables. So I hope the video was quite useful for you. I hope you have understood the concept and relation between variance, standard deviation, covariance, and correlation. These terms will definitely help you out to understand the further analysis and results produced by different data analysis softwares. Especially when you conduct structural equation modeling, you often come across the terms covariance and correlation, which are helpful in determining the convergent validity as well as discriminant validity. So I hope you enjoyed and learned a lot.